Hi, so this is a video on augmented generation. I have been working with a bit of language models, trying to use augmented generation techniques. There are so many techniques that just come out every day. There are so many RAG workflows. Everyone has their own flavor of RAG. There's an advanced RAG, there's LightRAG, MiniRAG, NanoRAG, GraphRAG. There's just so much. There's just so much. And yeah, I just thought I'll try to do something on that. Just try to explore the options that are there, and then see what's different with each of them. And yeah, so why augmented generation even? So large language models are pretty powerful, right? But they have their own limitations. The issue is they are trained on the static set of data, and they lack any real-time knowledge. They don't have any updated databases. They cannot provide any personalized answer, or they don't have any access to any private data that you might want it to be aware of. You want to provide it context about. And there's also the problem of reliability with large language models, because validating LLM output is always going to be an issue, and reliability is concern, because there's hallucinations with LLMs where we have LLMs making up facts, being convinced that they are correct about something that's entirely wrong. And then suppose you do want to improve the or update the data that the LLM is trained on. You have to kind of retrain the entire model, these large language models, and there's a high computational cost that is tied to it, which you want to avoid, because the model itself is pretty capable in terms of modeling general understanding of the language, but then it might not be familiar with specific terminology that domain specific knowledge, specific terminology that might be specific to that specific use case, or again, like any private data that you want it to be aware of when it's answering something. So for all of these kind of use cases and concerns and issues, augmented generation came up, and these augmented techniques can help mitigate these issues. Augmented generation is being used by a lot of the current implementations by OpenAI, Google, Anthropic, and yeah, I just took the AI practitioner exam by Amazon, and Amazon Bedrock also has like a knowledge base feature to build RAG workflows within their ecosystem. And I've also been working with like a lot of local LM inferences, a lot of these open UI. So there's this UI called Open Web UI, which also has like a knowledge base feature. Everything is based on these augmented generation techniques, new features that have been coming up. And as I was mentioning, there's just so many flavors of these augmented generations every day that claim to be better than the traditional naive RAG. Anyway, let's look at what RAG is initially. So we want to provide it more documents with like real-time knowledge and more uh, additional information that we want it to be aware of, adding in more context. So what we do is we take these documents, kind of create like a database that is indexed by embeddings. So we embed the documents, split it into chunks, embed the documents, create embeddings, and then put it in our database, and we have like an indexed database. And then so this is a vector database, so that we have like these vector embeddings. And then once we have a new query, we generate an embedding for the query itself, and then we try to match the top n documents that are most likely to have the relevant content that is required to answer this query. So again, it's like a similarity matching. There's this retrieval stage, and then the final generation stage. So the performance of RAG systems depend heavily on this retrieval stage, because it can only perform as well as the content that is being retrieved based on the query. Because what happens is that once we retrieve these documents from the vector database, we get these retrieval relevant documents added to our initial question, and then send it to your LLM for your final answer. So it only works as long as the relevant documents are correctly fetched by this retrieval step. So there's also like an initial pre-processing step that is involved with RAG, because you need to kind of pre-process this entire database that you want to include in your workflow. you have to break it into chunks, generate embeddings, and then create your own vector database for this purpose, so that you can, during inference stage, you can fetch that directly and then um, pass it on to your LLM as part of context. There is a slight increase in latency as in comparison to just querying the LLM directly, because you are embedding the query, performing like an embedding matching, similarity matching, retrieving these documents from the database, and then adding it on as context to your query before you even try to query the LLM and get an answer. So there is an increased latency, but then of course we have the benefit of including any added context that you want to include for your query. So the steps again, yeah, so pre-processing the data and creating this vector database indexed by the embeddings, and query processing, document retrieval during the query stage, and then augmented generation. Okay, moving on. So yeah, again, LightRAG, of course, as the output is tends to be more reliable, because we are providing more context, we are providing more we can kind of instruct the LLM, just use this data to answer these questions, do not use anything else, do not if there's something else that cannot be answered from this context, please say I don't know. So it reduces hallucinations by a great extent, and we can also kind of fact check, and there's also like a RAG workflow called FCAG, fact checking augmented generation, where you can kind of provide like a set of facts, and then you can code like a specific fact as the source for this output from the LLM. So yeah, so you can mention the sources, where you got the data from, where you got this input from, and in turn we all have like a more reliable output with RAG. And we have the option of a dynamic database. So this database can be as huge as you want, as big as you want, because you can just keep adding as many documents that you want to include, and every time a new query is processed, you're just going to kind of fetch the top relevant documents for that query, and it's still going to work. So we have the option of a dynamic database. You have it enables like real-time updates without retraining the model, and optimized performance, because we did not need to feed all the data for each query. You do not need to, suppose you have this database and you opt to include that data, all of that data, as part of your context every time you query the model. That's going to be like a large context window might be required for that, and you're still looking at a lot of irrelevant data. Yeah, and this is optimizing that by kind of fetching just the relevant documents that is needed for this query. So optimization, scalability, because again, the database size just there's no limit to it. You can just kind of keep increasing the database size. Modularity. So each of these components in this RAG workflow is its own thing, and you can kind of swap it out with any other model. The database could be swapped out. The data vector storing, the embedding method could be swapped out. The similarity matching, anything could be just modified at any point, and everything is just abstracted into its own component. The embedding, the LLM that you finally use to kind of query it, everything can be modularly modified. And personalization, so giving the LLM access to your own personal data and any other context that you want it to be aware of before answering the question that you ask it. Of course, there's the issue of privacy, which is solved by local inferences. So yeah. Cons, well, yeah, it is heavily dependent on retrieval. Poor retrieval results in poor generation, because without the relevant documents, there's only so much that the LLM can know about the query that we ask it. All right, having to maintain like an external knowledge base, that could be a potential con, because there's going to be an increasing database that you want to maintain and have access to at all times. It should be available for the LLM to be able to fetch the relevant documents at any time. All right. All right, now there's like these ton of alternatives that keep coming up. There's advanced RAG, cache augmented generation, CAG, knowledge graph augmented generation, memory augmented generation for like long context conversation based memory, the FCAG, the fact checking augmented generation, where you use like a database of facts that could be cited as the source for the output that the LLM gives, and the output generated by the LLM is then checked against this database to ensure that these facts are being maintained. So yeah, and there are also like multiple hybrid approaches where you can kind of include cache as well as the knowledge graph as well as memory augmentation. All right, and the final approach, I mean, the alternative to augmented generation itself is retraining, where you include all of these new data that you want to include as part of your training data for the LLM and train the model, recompute the weights. Yeah, excuse me. All right, cache augmented generation. We have so in this case, this is usually applicable when there's like a lot of frequent repeated queries, like frequently asked questions that you want to keep answering. It's sort of like let's say like a customer service center that has like repeated questions, similar questions that you want to get answers for. It helps with that because you don't have to kind of use the LLM to generate answers every time. You can save it in a cache. There's also a difference in how this works because there's a bit of pre-processing stage again, where you preload the data with to the model. The model has to create this kind of a key value cache, and there's a bit of model recomputation. And so we create this custom knowledge base. The knowledge cache is created, and the LLM has this cache ready. So whenever a query comes in, we kind of check the cache first to see if it has already been generated, and then if it is, we can just take the response from that. Else the LLM kind of does it again. In this case, however, the knowledge base is kind of used to recompute the model weights. It is kind of like fine-tuning, and again, it is going to be limited by the context window of the LLM itself. So this knowledge is preloaded in the external context of LLMs, and this is RAG and this is CAG. Okay. All right. So yeah, the steps are preload the data to the model, you recompute the weights, and then create this kind of a knowledge cache that can be used for fast access, fast response. And then every time a query is processed, it goes through the cache and then goes through the LLM. It has a higher accuracy because this entire custom knowledge base is kind of used to pre-compute this knowledge cache to be a part of the initial step when going through the LLM. So yeah, but then again, we are limited by the context window because we cannot use as infinite data to kind of set up this knowledge cache. In RAG, we're not limited by the size of the database because we can have as many documents as we want, and we can still just fetch the relevant documents that we need for the query. But for this, we are limited by the context window. The accuracy is higher because we have the entire custom knowledge base loaded. We have access to all of that data before answering the query. The latency is lower because once we do this pre-processing step, preloading data step, the inference stage is just kind of a single run through the LLM. It's just a forward run through the LLM, and so the latency is definitely lower. And of course, we have the benefit of having a cache which has like frequently answered questions readily available for being fed directly. And cons. So yeah, it is harder to update the data because if you want to update this custom knowledge base, you're gonna have to kind of retrain or recompute the model's cache. You're gonna have to set up this cache again. So it's gonna be take some time for that. All right. Moving on, this is the knowledge graph based augmented generation. This is usually used for more of a reasoning or kind of use cases where the relationships between different entities matter. Is usually for reasoning models, I would say. And we end up using the data set. That is again a pre-processing, preloading kind of step where we process the entire data set, that custom data set that we want to include as part of context. We create a knowledge graph containing entities, relationships, and any other facts that are tagged to these entities. So the actual process is a bit complicated because there's a bit of so that's like semantic chunking, and then we use an LLM kind of extract information from the data. You identify these entities and relationships using another LLM, and then align that against the input documents, and then you have like so CAG uses also like a template graph that it kind of aligns against for like similarity, and then finally generates like a domain based knowledge graph for this data set. And every time a query is made, there's like vector search on these documents as well as graph search on it selects like a subgraph that is relevant to the particular query, and then these both are combined and sent to the LLM, and finally we have the output. So yeah, the user inputs a query does a query decomposition to kind of determine what section of the graph we need to fetch, and then there's like retrieval and reasoning. So reasoning in both the LLM as well as in the knowledge graph, knowledge base. Subgraph relevant to the query is extracted using semantic search or graph traversal, and the relevant documents are also fetched, and then we finally generate based on this. All right. Pros: the responses are grounded in a well-defined knowledge structure. Of course, we are modeling on the data. We are kind of studying the data before we even try to query it. So the responses are supposed to be, the augmented generation is supposed to perform better in general. It should be able to identify these relationships better and give us better responses. And there's more consistency. So it reduces hallucinations further because, again, we work on these relationships and entities, and it's just going to work on based on that, and it's not going to assume any of these relationships. There's improved reasoning, enables better inferencing by leveraging explicit relationships in the knowledge graph itself. All right, and cons: there's this additional latency with fetching the subgraph that is relevant to the query. So there's a higher latency here, and the pre-processing preloading step is kind of heavy in this workflow. So it's kind of harder to update the data every time and kind of generate this knowledge graph or update the knowledge graph again. So yeah, because any new or additional information must be again passed through the query decomposition, building the knowledge graph, determining all the potential entities, relationships with the previous entities. So yeah, so slightly harder to update the data compared to like RAG, where you can just kind of push it into the database and just create embeddings for it. But yeah, it is supposed to perform much better than RAG or CAG. And then there's other approaches. So there's memory augmented generation, so persistent memory for long conversations, fact checking, augmented generation, cross-referencing with fact databases. Okay. Well, with memory augmented generation, they claim that it enables continuity across multiple conversations, adapts responses based on previous exchanges. Users don't need to re-explain any previous discussions. So mostly for conversation-based workflows. But the cons are requires efficient retrieval mechanisms to avoid bloated context windows. We don't want to include too much context. We don't want to include the entire conversational history. All right, and storing user interactions could also pose security concerns with respect to privacy. And with fact checking, well, yeah, the pros are helping ensure that the responses are grounded in these verified facts that we provide, and it increases the credibility in critical domains like could be useful in like law based use cases where we can kind of directly reference the specific rule that we want to use for this inference or view. So yeah, we can also provide these sources for the claims that the LLM makes. Cons: it is slower. There's an additional retrieval step with the fact checking. Then the accuracy depends on the quality and coverage of the external fact sources. Again, it can only verify with what it is provided. So if it's part of the fact checking database, it's going to verify it. If it's not going to be there, it's not going to know whether it's correct or not. All right. Contradictory information in fact database can lead to uncertainty. All right. When to use what? If real-time updates matter, and if there's going to be a lot of changing information that you don't want to keep processing every time, and if accuracy is not too much of a concern, RAG is your best option. If latency is a concern, and if there's like not going to be too much changing databases, if it's more of a static database and you want answers as soon as you can, you would use CAG. And if you want deep domain knowledge and like being able to model and reason across relationships and how the different entities and components function together, you would use KAG. And if handling user history, so conversational use cases, MAG, and of course fact checking, if fact checking is crucial. All right. There's also hybrid approaches that you could potentially use. You can combine any of these and build your own workflow, your own flavor of RAG. And conclusions. Okay. In general, augmented generation promises reduced hallucinations, increased credibility and reliability, and I would also say it's pretty much use case specific with what you want to use for your application. And potential next steps in this direction could be multimodal augmentation, um, hybrid generalizable augmentation, and better retrieval mechanisms to ensure or enhance the credibility of or the performance of the LLMs itself, because that is the most optimal approach I would say right now with respect to not having to pre-compute. Yes, with dynamic databases, that is the most optimal approach right now. And I have actually been working on testing these out locally. I was able to run RAG on using a vector database called ChromaDB, and it did work pretty well. I've been working with local inferences using Olama, using Llama 3.2, and then now Gemma 3 12 billion. It does run pretty well, and RAG is pretty impressive because it provides us the option of updating our database at any point. And just yesterday, actually, I got to test out LightRAG and MiniRAG. So LightRAG and MiniRAG, they are based on graph-based, knowledge graph-based approaches. But then one difference that they propose is like a multi-level, so dual level retrieval paradigm. So they kind of generate this graph, and then they extract keys that are at two different levels. So like a high level overarching theme, or more general based on the query, and then more low level keys, and then use these two to kind of provide us with a better response, because they provide comparisons against current alternatives like LLMs. There's a significant improvement over LLMs, because 32% to 67% almost. And then even against like GraphRag, there's a significant improvement across different domains as well. So right now this approach kind of seems to perform very well in compared to the other RAG workflows. And the same team also came out with like a variant called MiniRAG, which I got to implement. And let me see if I have that. Oh, okay. Yeah, so this is actually the knowledge graph that MiniRAG generated on like a sample database. Let me zoom in. So it creates all these entities, and then these lines are the relationships. So city is entity, meeting is an entity, and then the meeting will take place in the city. So that's a relationship. So I used Gemma 3 12 billion to kind of generate this graph. The performance heavily depends on the model that you're going to use to build this knowledge graph. Because wait, let me actually show you what I got with Llama 3.2 1 billion. Okay, with the same data set, with the same sample data set, this is the knowledge graph that was built by Llama 3.2 1 billion. So it is heavily dependent on the complexity of the LLM that you want to use for this modeling. And of course, like the more it is capable, the more rich your knowledge graph is going to be, and eventually the better your query processing is going to be. And yeah, the process is actually so it takes up the database, it queries the LLM to kind of determine the entities, relationships, and it requires this output in like a specific format. And in fact, when I was using Llama, wait, this was actually with 3 billion, because with 1 billion, I could not even get these relationships, because Llama 3.3 billion was giving these minimal entities and relationships in the correct format, but then Llama 3.2 1 billion model could not even get the output format correct, because it was just giving me these potential entities in like a text format, instead of formatting it to the being able to generate this knowledge graph. It was required to do that in like a specific format, and I was not getting that with Llama 3.2 1 billion. But yeah, this is with 3 billion. I am sorry about that. Anyway, it does perform really well with like a more complex model, and I did try out like a sample query on it, and it does work good. The pre-processing step, it took me about, for like 15 text files, for like 3 files, it took me about 15 minutes. So it does take a lot of time to kind of generate this graph and all these relationships. Again, it depends on the complexity of the model, because on Gemma 3 it took this time, but then it should be much slower, much faster on a smaller model. Yeah, so the more time it takes, the higher the quality of the knowledge graph generated is, because yeah, this is the difference you could expect. Anyway, yeah, I've been working on these augmentation techniques, just trying to test them out locally. I'm also working on a GitHub repo to kind of set up starter codes for all of these methods. That should be updated soon. And yeah, with that, that's kind of all I wanted to talk about with augmented generation. All right then, cool.